All right, for this section 3.1, we are going to start talking about functions. So we've got a lot of different topics we're covering today under functions. We'll identify functions, domain and range, independent and dependent variables. Lots of topics with functions. So for our warm-ups, we are evaluating these expressions. Notice there is not an equal sign. We're not solving anything in the problem. We are simply plugging in and simplifying. So I would rewrite the problem, but instead of putting an x, what would I put? 2. A 2, and what do I usually put by the 2? We could put parentheses or a dot to know that we are multiplying those. Minus 2, and then in for y, I'm putting a negative 5. What is 3 times 2? 6. Minus 2 times negative 5. Careful. Negative 10. Okay, we had a minus sign, and then 2 times negative 5 is a negative 10. Subtracting a negative means we're really doing what? Adding. So this really becomes 6 plus 10, which is 16. Okay, this is something that we covered in our review skills chapter at the very beginning of the year. On number 2, I'm going to show my work off to the side here where I've got some more space. My first step is to rewrite the problem. And again, plug in for x and plug in for y. After I do that, what should I do next?
Don't you add like the like variables and stuff like that? You don't add those?
We don't necessarily have any like terms just yet that we can combine. Multiply what? Good. We have to follow our order of operations. So remember parentheses, exponents, multiplication, and division. Instead of rewriting this as minus a negative, how could I write it? Dominic?
Plus 5.
Good. We could just rewrite it as plus 5 instead of minus a negative 5. Dominic, what else can I do?
Either negative 3 plus 9 or just 1 by 1 and 5.
Okay, so all that's left is addition. So typically we like to work left to right. So negative 3 plus 4 is 1. And then we add the 5 and we get 6. Questions about evaluating expressions? Anybody need more time on their warm-ups or their objective? Okay. All right, our vocab, or the start of our vocab, talks about a relation which pairs inputs with outputs. A relation is very general. Matches up inputs with outputs. Inputs we usually refer to as our x-coordinates. Outputs we usually refer to as our y-coordinates. A function is a special type of relation that pairs each input with exactly one output. Okay, so you could kind of think about relation as relationships. Like you've got lots of relationships in your life. Friends, family, things like that. Okay, everybody has lots of friends. But hopefully, if you are like, in a committed relationship, like a boyfriend, girlfriend, or whatever your preference may be, you only got one. Right? Hopefully. Should. Okay, so relations are general, okay? Functions are specific. You only got one to one. Okay, now that's, in an ideal world where we're all behaving ourselves appropriately. Questions about our vocab? Okay. So we are to determine whether each relation is a function or not. So on this first slide, we've got ordered pairs. Okay, so if we flip back and we think about it, each input goes with exactly one output. So each x goes with only one y. So if we look at this first one, so we've got an x of -2 paired up with a 2. Do we have any other -2s for x's?
No.
Nope. So that one's fine. Next one is a -1. Do we have any other -1s for x's?
No.
Nope. Next one's a 0. Do we have any other x's that are zeros? Okay, next x is a 1. Any other x's that are 1s? Next one's a 2. Any others that are 2s? No. So each x only got used one time. Does that make sense? Okay. So each input got paired with a different output. So this one would be considered a function. Each input goes with just one output. Now, I know that it can get a little tricky because we see some outputs or some y's are used over again. And that's technically okay in this case. But each input has to go to only one output. Does that make sense? Okay, so each x can only get used up once. So this one is a function. So we'll compare that to letter B. Which input or which x value gets used twice? The 4 gets used twice. So we see it in this first point, and then we see it again in another point. That means that this cannot be a function. Okay, 4 is trying to match up with 0, and 4 is trying to match up with 3. That's not allowed. So this is not a function. You can reuse your outputs or reuse your y's, but you cannot reuse your inputs or your x's. Questions, concerns? Need more time on this slide? Okay. Well, let's see our next set. So we have a table on letter C. We could rewrite our table as ordered pairs because they do give them to us as x, comma, y. So if you wanted to, you could rewrite these as ordered pairs. You do not need to. This is just a different way of representing it. So on letter C, what do we think? Is this going to work for a function or not? Why not? Good. We use the same input or the same x twice. So because we used that 0 2 times as an input, this is not a function. All right. Letter D is called a mapping diagram. We'll talk more about that in another lesson. But this mapping diagram can also be turned into ordered pairs if we need to see it that way. So it shows that -1 maps to or pairs up with a 4. It shows us that 3 pairs up with what? 15. And it shows us that 11 pairs up with 15. So could this be considered a function? Yes, why? Good, they didn't use the same input twice, or they didn't use the same x twice. So this is a function. Yes, it is a function. You can double up on your outputs or your y's. You cannot double up on your inputs. Questions, concerns? Function versus not a function? Okay. The vertical line test down at the bottom of the front of your notes. A graph represents a function when no vertical line passes through more than one point on the graph. So a couple examples are shown there for you. So for this left graph, how many points does that dotted line go through? One. So that would be a function. If it only goes through 1 point, that's considered a function. How many points does it go through on our second graph? 2. We see it crosses it once up here towards the top and then once again a little bit later. So this is not a function. If it goes through more than 1 point, when you put a vertical line in, it is not a function. Of course, we should know that vertical lines go which way? Up and down. So it's a vertical line test, not a horizontal line test, not a slanted line test. It's got to be a perfectly vertical line. So any of those problems we did, A, B, C, or D, that we just did, if we had graphed them on a coordinate plane, we would have been able to put lines through it and seen that if it was a function, it'd only go through once. If it's not a function, it goes through more than once. Another thing I want to mention about the vertical line test is that sometimes you'll have a function, not a function, you'll have a relation where it'll work sometimes but not other times. So if you want to add one more example off to the side here, if we were to have a line that looked something like this, a squiggly line of sorts. If I do some vertical lines, like over here off to the side, or off on this side, how many times does it touch over here? Just once. How many times does it touch on this one? Just once. But if I use another line to test somewhere else, now how many times is it touching? 3 times. 1, 2, 3. So this is still going to be not a function. Okay, I'll just put a little red X in the corner. That's not a function because even though it worked some places, it didn't work everywhere. Questions, concerns about the vertical line test? Okay. We'll keep it moving then. Using the vertical line test, determine if each graph represents a function. So I'll give you a couple minutes to think about this. Put in some vertical lines and let me know what you think. I wouldn't just test one vertical line though. I'd put in a few of them. And see if you believe this is a function or not. On number 2, letter A, do we think this is a function? Yes or no?
No.
Heard several no's. Do I have any yeses? Well, let's just talk about A for now. So if I start putting vertical lines through here, let's just see. That only goes through 1 point. But when I go over here, how many points did it go through on this one? 2 points. It went through here and here. And if we go through 2 points, then it is not a function. Not a function. What about letter B? Heard a few yeses. We think it's a function?
Yep.
Yes, I agree. This time it is a function. If I put in my vertical lines all the way through this graph, it only ever touches it one time. Okay, so we go through this whole thing. Every time my vertical line only touches one point. So, yes, it is a function. Okay, on your homework, if it says determine if it's a function, you can either put yes or no, or you can put function or not a function. Something like that's fine. Questions about the vertical line test? Concerns? Warm, fuzzy feelings? Cold, prickly feelings? Void of all emotion? Some of us are. Okay, we'll keep going then. All right, next up we got another set of terms. So I should see everybody filling in their blanks on their note sheets. The domain of a function is the set of all possible input values, which means we're usually talking about the x values. Domain, input, x. The range of a function is the set of all possible output values, which means we usually refer to the y values or y coordinates. Domain and range are listed from least to greatest. It can be written in curly brackets or with inequality symbols. Anyone remember what our inequality symbols are? Dominic?
Greater than or equal to or less than or equal to.
Good. So greater than or equal to, less than or equal to, sometimes just greater than or less than. So we've got two different ways that we can state our domain and range. There is technically a third way called set notation, but we won't worry about that in this class. You might see it in a couple years in Algebra II. Anybody need more time on their blanks here?
You mean in like...
All right, on example 3, find the domain and range of each function. Now, just looking at these as pictures, what do we notice that's different in general from problem A to problem B? What does problem B have that problem A doesn't? A line. Okay, so notice that we've got this line here drawn in. That means that there are lots and lots and lots and lots and lots and lots and lots of points that are on that line, which means we won't really just use our curly brackets. So I'll show you what we mean by that. On letter A, since we have individual points, we can use curly brackets and just list our numbers for our domain and our range. So let's look at this just a little further. First, let's just talk about what these points are that are on this first graph. Now, when you do this on your homework, you might not need to list out all the points separately. But for this problem, we will, just to show exactly where this information comes from. So let's start at the bottom left. What are the coordinates of that point? Good, -3, -2. Remember, to get to a point, if we go left on the x-axis, that's negative. So we went left 3, -3, and then down 2 would also be a -2. What about the next point? What are my coordinates? -1, 0. The next point over, 1, 2. The next one over, all the way up here, is 3, 4. Questions about how we came up with those numbers? All right, if we are talking about our domain, I'll use a capital D to represent it. I'll put some curly brackets in. Domain refers to which values? Input, which we usually are calling our x values. Domain, input, x. Those words should all be associated with each other. So we usually list it from least to greatest. What's nice about how we set this up is we went from least to greatest. So what is my smallest or least x value? -3, comma, the next one. -1, comma, the next one. Comma, the next one. 3. So because we just had points, we can list our domain just as numbers. Questions about the domain? Okay, then we do the range. I'll use a capital R. My curly braces, what is the lowest number from my range? -2, and then, good. Questions, concerns? Okay, that's going to be a little bit different than how we're going to treat letter B. Okay, letter B contains so many points, there's no way we could list them all. It contains points that are at decimals and fractions and teeny tiny ones, so there's no way we could list them all out. So instead, we're going to use our inequality symbols. So our domain, again, is going to refer to x values. So I am going to sandwich my x in between two inequality symbols. Why do you think I put bars on my inequality symbols? Dominic?
It represents or equal to. I'm actually looking at the less than sign.
Yep, the less than or equal to signs. Why did I put bars on them? Think about these dots here. That dot and that dot, they are closed in. Okay, so we can equal those numbers. I'm going to do the same thing with the range. I'm going to sandwich y in between my inequality symbols. So then we have to think about what numbers go on them. So for x, what's the smallest or lowest x coordinate that you think I would come across? Not -3 because we don't have a point out here at -3. That's close though. -2. Okay, so all the way out here on x, we've got a -2. So -2 is my smallest x. What about my biggest x? 3. So we have a point up here that would drop down to that 3. So all my x values are going to be somewhere in between -2 and +3. Questions about my x interval? Okay, so now we kind of have to switch our view and kind of look at this sideways. So now I want to focus on my y-axis, the one that goes up and down. So what's the lowest y value that I hit? -1. So see, here we would be at -1. And then what's my biggest y value? A +2. Okay, so we kind of turn this almost into like a box so that we can see where we're at for our domain and our range. Questions, concerns about that one? Okay, so if you're given individual points, you can just list the numbers. But if you're given a graph that has some sort of line on it, you're going to have to use your inequality symbols to do it. We ready to move on from this? Okay. So I'm actually, before we do our independent and dependent variables, I'm going to flip back all the way back to letter A, I just want to, for a second, talk about domain and range on this problem because it's a little bit different from what we've seen. Now, since we have points, I know that I can just list them out with my curly brackets. Okay. So what is my lowest x value that I see on letter A? -2, and then, and 2. Okay, so we got all our x values. The way that this one's a little bit different is when we come to our range, because first of all, we're not just going through and listing out what was paired up with what we just listed. Okay, we always start with our smallest value. So what's the smallest value from my range? 0. And then what? We only list each number once. So that's the other difference here. Even though we have a bunch of zeros, we're only going to write 1 0. So my next one would be a 2, and then I'm done, right? We only had 0s and 2s. So your domain and range do not have to have the same amount of numbers in them. Okay, we only list them one time. We list them from least to greatest. Questions about that? I just wanted to show you a slightly different example. Okay, so we're ready to go back to our independent and dependent variables. So we're on that last page of your guided notes. The independent variable of a function represents the input values. So that means any values of the domain, they will be x values. The dependent variable of a function represents the output values. It depends on the independent variable. So we don't know what it's going to be unless we know the independent variable. Those are our y values. So we've got a lot of words that we need to be associating together. Independent variable, input, x, domain. All of those get associated together. Dependent variable, output, range, y value. So we've got a little equation or function down here that shows us the independent variable is the x, the dependent variable is the y. Anybody need more time on that box? Okay, we'll keep going then. Identifying independent and dependent variables. The function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variables. So what part of this is under our control in this situation? We decide how many what? Gulps. We decide how many gulps we take. Does that make sense? That's up to you. If you have a water bottle or juice bottle, you decide how many gulps you take. So the independent variable is the number of gulps. Another hint that they gave you for that is that they gave gulps the variable x. The dependent variable, so what changes based on our gulps? The amount of juice that's left. So again, they kind of helped you out. They gave you a y. The amount of juice remaining is our dependent variable. Amount of juice, you could put remaining or left in the bottle. Questions about independent versus dependent variables? Okay, so they are telling us that the domain for this function is 0, 1, 2, 3, and 4. So 0 gulps, 1 gulp, 2 gulps, 3 gulps, 4 gulps. We have to find the range. How are we going to do that? How am I going to know how much fluid is left if I have not taken any gulps? I haven't drank out of it at all. Do what? What do you mean by that? I think you might be on the right track. Think about what we haven't used from the information they gave us. What big piece of information didn't we use yet? The what?
12.
We haven't used the 12 or
X.
the x or the -3 or the y. We haven't used this whole equation that they gave us. We haven't used that at all. So we need to use that to help us find the range. If they gave us 5 domain values, 0, 1, 2, 3, and 4, 5 domain values, how many range values do you think I'm finding? Dominic?
Can you call on someone else?
Sure. If they gave us 5 domain values, how many range values do you think I'm going to have this time?
2, 1 or 2.
So let's think about it. If I've taken 0 gulps, is that going to be the same or different than taking 1, 2, 3, or 4 gulps? Different. If I take 1 gulp, is that going to be the same or different from taking 2, 3, or 4 gulps? So each one of these is going to be different. So if I have 5 domain values, I'm going to have, James, 5 range values. How do you think we're going to find them? No, not sure still. Let's take it a step back. Domain is associated with which variable, x or y? X. So if domain is associated with x, what do you think I need to do with these numbers? Put them in for x. If domain is x values, and they gave me domain values, I'm going to plug those in for x. When I plug those in for x, what am I going to be solving for? Y, and y gives us our range values. We see how this is going to work? We are going to plug in x's, the y's go in our range. So I'll go ahead and set up my curly brackets for my range, and then we'll just put in our range values as we find them. We might have to reorder them later. So first up, what am I plugging in for x? 0. -3 times 0 is 0 plus 12 is 0 plus 12 is 12. Next up, what am I plugging in for x? Where am I getting the numbers that I'm plugging in? From that list they gave me. So if I plugged in 0, next I would plug in a 1. -3 times 1 is? -3. -3 plus 12 is 9. What am I plugging in now? The 2 Negative 3 times 2 is negative 6 plus 12 is 6. Next, what am I plugging in? The 3. Negative 3 times 3 is negative 9 plus 12 is 3. Last, I'm going to plug in the 4. Negative 3 times 4 is negative 12 plus 12 is 0. So when I go to list my range, my smallest y value was 0, and then 3, and then 12. So this represents how much fluid I would have left in my bottle, how much juice I have left after I take those many gulps. Why would it not make sense for my range to go bigger than 4? Why could I not take 5 gulps? I don't have any juice left. We already saw that after 4 gulps, I have 0 ounces left. My bottle's already empty at 4 gulps. So taking 5 gulps doesn't make any sense. Okay, questions about domain, range, independent, dependent variables, functions, not a function, the vertical line test. We've covered a lot of different ideas so far today. Okay, nothing on this slide. Okay, your homework is printed at the bottom of your guided notes. It's nice and handy for you. It's also up here on the board right now.